On an adventure with the smallest glucose to the cellulose in the trees, the brothers Pratt are going places you never get to see. Hanging with their ATP, get ready, it's the hour. We're gonna see some cellulose today with redox power. Krebs cycle and lizard glide, proton surge and lion blast. Today we'll be learning about cellular respiration, and it all kind of starts when you eat something. Potatoes have a lot of starch. I am starch, god of glucose. Oh, Go. I'm glucose. Now the glucose enters the cell. As it enters the cell, it goes into the cytoplasm. Here, it will undergo glycolysis. Hey, what's up?
You need me?
Not yet. Oh, are you guys gonna, do... okay, alright.
Yeah.
Ah! Oh my god! Oh. Okay. Hey, look, now there's two of me. Oh, now there's two of you too. Yeah, why? Jinx. Anyway, those are some nice electrons you got there. Yeah. Thank you. Hey, is that a hydrogen? Oh man, wow. Feeling weird. You know the drill. Wait, what? Aw, come on. Hey, is that a hydrogen? Oh, this happened to the other guy too. Okay, so we're out. Well, I guess that's the last we'll see of those guys. That's what I call foreshadowing. Oh, now there's I thought you guys blew up. There's four. Yeah, we're back. All four of us are here. You got the stuff? Yeah, I got the stuff. Oh yeah, give me some of that. Oh yeah, oh yeah. Oh yeah, me too. Oh yeah. Oh, yes, please. That was some nice stuff. I think me and everyone are pretty satisfied with our care. Yeah, that was some... Oh my. Oh my. What you just saw was glycolysis. It's when the glucose enters the cytoplasm, and there's no need for oxygen. Immediately, two ATPs become two ADPs by splitting up the glucose into glyceraldehyde 3-phosphate. There are two glyceraldehyde 3-phosphates. Then for each glyceraldehyde 3-phosphate, there is an NAD+ that takes electrons from it. The NAD+ later bumps into some hydrogen, becomes NADH, leaving two coenzymes of NADH for this step. Then after that, the NADP come in and the glyceraldehyde 3-phosphate make the ADP into ATP, making 4 ATPs for this step and a net profit of 2 ATPs because we had to use 2 at the beginning. Then after all of that, the glyceraldehyde 3-phosphates become pyruvates, so you get pyruvic acid or 2-pyruvate.
Go.
Now glycolysis is over, and the pyruvates move to the mitochondria to begin the aerobic process of the Krebs cycle. Hey yo, we need you now, so you can come down off of there.
Woohoo!
State your name and your mission for the address. I'm Oxygen, and my mission is, it's basically just take a carbon from this pyruvate. Oh, is that the guy? Oh, what's up? What's up, pyruvate? Oh, what's up, Oxygen? My carbon. power of the carbon. It made me something else. I'm now CO2. I guess I have to leave the cell now. It's been a while. Wonder what's outside of the cell. Whoa! Whoa! Oh. Me? Well, okay. You pushed me into acetyl-CoA. Now I am citric acid. Oh my. Oh, what's up, oxygen? What? Please, my carbon's been stolen from me. I don't know, it was his oxygen. He looks so suspicious, I gotta be honest. That oxygen, that fella, it was a weird guy. He stole my carbon. He stole my carbon. Did you see him? Oh, please, no! My electrons! Oh, why? Oh, this new fancy Is that a hydrogen? Whoa! I feel the power. Oh, please, no. Not again. Not again. Please. Play. What? Oh, hey. What's up? Nothing much. Secret handshake? Secret handshake, yeah. ATP. Hey, this is some nice electrons you got there. Very nice electron. Is that a hydrogen? Whoa! Now, I have FADH2. I'm back. Well, you know the drill by now. Wait a minute. I've heard that. Oh, again. Pretty nice electron I got here. Oh, is that a hydrogen? Interesting. Whoa! I'm now NAD. With the loss of my last electron, what am I? I'm oxaloacetic acid. That's what I am. The oxaloacetic acid in the last step will be used to restart the cycle again when it is combined with the acetyl-CoA. Now that the Krebs cycle is over, we start the ETC, the electron transport chain. It's in the mitochondria. And for this one, we're going to be using animation. Wait, why are we switching? I think this thing's pretty good. Why do we need this animation? Well, you see, we just don't have enough of me to be able to do that, so, yeah. What are you talking about? Animation! We are still in the mitochondria. The intermembrane space is on the outside and the matrix is in the inside. The intermembrane space has more protons than the matrix, creating a concentration gradient. The protons want to get past the membrane to establish equilibrium. Here we have the ETC, or the electron transfer chain, which consists of proteins 1, 2, 3, and 4. Proteins 1, 3, and 4 move protons from the matrix to the intermembrane to maintain the gradient. Protein 2 regulates pumping of protons in protein 3 and 4. To maintain this gradient, the proteins need energy. This is where the coenzymes come in. We have 10 NADHs and we have 2 FADHs. They deposit their electrons at the proteins, and their electrons will flow from one protein to another and kind of like jump around while they're in each. And while they're jumping around, they release some energy. The proteins will harness that energy and use it for pumping protons. At the last stop, in the final protein, the last electron acceptor is revealed, which is oxygen. The oxygen plus 2 new electrons it just accepted finds 2 free hydrogens and becomes H2O, the most useless byproduct of any reaction. So, why are we pumping all these protons if the membrane is stopping them from leaving? Well, you see, the ATP synthase is that reason. It's kind of like a water mill. The protons will push from the intermembrane, which has more protons, to the matrix, which has less, because they want to go with the concentration gradient. And by pushing into it, it will make it spin. And this will produce energy, which the ATP synthase uses to attach a phosphate to an ADP, making ATP. This process can result in up to 34 ATPs at its best. Glycolysis is over. We can just get Krebs cycle started. We just need that oxygen guy. Oh no! It's time for fermentation.
Ominous. Two of my least favorite traits in a room.
Oh look, a button.
Huh? Private, don't. Now what have I told you about?
Sorry, what?
Hey, you don't leave yet. Don't leave. Okay. Yes, and now give the pyruvate your electrons. Here's the electron. Oh, an electron. Why, thank you. I am now lactate.
Say something, I'm giving up on you. I'll be the one if you want me to. Anywhere I would have followed you.